All right, so this is part two of three of our dead guys talk about, how we came up with our atomic theory, our atomic model that we've got today. So the first guy we're going to talk about today is John Dalton. Okay, so we've jumped up. We started with Democritus in the last video, and that's ancient times, and now we've moved up to John Dalton, which is late 1700s, early 1800s. So he proposed the atomic theory. Okay, he was the first one to come up with an atomic theory, and he did this in 1803. Okay, and the atomic theory has four parts. First part, each element is composed of extremely small particles called atoms. Okay, so, Democritus was right. He was right about atoms. Okay, the second part of Dalton's atomic theory is that all atoms of a given element are identical. Okay, so they're all identical. However, they do differ from those of any other element. Okay, the third part of his theory. Okay, third part of his theory is atoms are neither created nor destroyed in any chemical reaction. And then the last one, a given compound will always have the same relative number and kinds of atoms. Okay. So if you look at these, really none of them are his own thoughts. Okay. Each element is composed of extremely small particles called atoms. Democritus came up with that first, 1,000, 2,000 years ago, before him. All atoms are a given element are identical but different from those of other elements. That's pretty much the one that is could be called his own. Number three, atoms are neither created nor destroyed. That is, the law of conservation of mass. Lavoisier came up with that. And then number four, a given compound will always have the same relative numbers and kinds of atoms. That's Proust, law of constant composition. So he took all of these ideas and formed them into one atomic theory. So it's not like he did all the work. He just recognized all the information and was able to put it together. Okay, so next guy we're going to talk about is Michael Faraday. Okay, Michael Faraday, he invented the electric motor. All right, he developed laws of electrolysis. Okay, and he determined that electrical charges are responsible for holding atoms together. Okay. that's his main contribution. So, you know, the question that Aristotle got everybody with way back when, you know, how do they stick together? Well, Faraday figured that out. It's the electrical charges that are holding atoms together. Okay. Third guy we're going to talk about is Sir William Crookes. Okay, and really not the only thing he did, but the only thing we're concerned with is that he discovered radiation through cathode rays. Okay, he discovered radiation through cathode rays. That's pretty much all you got to know about him. J.J. Thomson. Okay, J.J. Thomson discovered the electron. Right? And he used cathode ray tubes to discover the charge to mass ratio of an electron. Okay. And what he did was he took essentially cathode rays, or these cathode tubes. He had a negative end and a positive end, and he put a magnetic field around it. Okay. First, he did it with no charge. Okay. He did not put a charge on it, and saw that everything was flying nice and straight through the tube. Okay. But when he put a charge on it, okay, where's our negative end and our positive end? Right, electrons are going through there. He found that, you know, they started to bend. Okay, they started to bend in one direction. And, you know, using his knowledge of, you know, how much they bent and where they landed, you know, he could tell what the charge to mass ratio was. Okay, and using this, he came up with the plum pudding model, or what we call the plum pudding model of the atom. Okay, basically what it is an atom is a nice solid circle. Okay, a nice solid ball, and it is just a big ball of positivity. Okay, just a ball that is mainly positive, and then interspersed in there, you've got these negative electrons. Okay, these negative electrons are just kind of in there somewhere. It would be more today would be chocolate chip cookies. Probably not a whole lot of you eat plum pudding or even know what plum pudding is. So if you look at this as a chocolate chip cookie, the chip part of it is, or sorry, the cookie part of it is the positive atom, and the little chocolate chips are the little electrons kind of interspersed in there. Okay. So plum pudding model, that's important for you to remember. Last guy, Robert Millikan. Millikan, spell his name right. Okay. Robert Millikan used the oil drop experiment to discover the mass and charge of an electron. Okay, and it's difficult to draw on here, but if you go onto YouTube and you search Robert Millikan oil drop experiment. There's several nice animations for you to determine, or for you to watch, to see how he determined the mass and charge of the electron. Okay, that is part 2 of our search for the atomic model.